let us consider this question asked in colligative properties, that is dilute solution in chemistry class 12. Why osmotic pressure is a better criteria for measuring the molar mass of macromolecules as compared to the elevation of boiling point and depression of freezing point. First of all, let us try to understand this question. See, that is, we know already osmotic pressure, elevation of boiling point, depression of freezing point. These are all the various colligative properties, and these parameters are very useful for us to determine the molar mass. First of all, let me explain how the molar mass is calculated based on these colligative properties. Now, what are colligative properties? Colligative properties are elevation of boiling point, depression of freezing point, increase of osmotic pressure, and relative lowering of vapor pressure. Now the question asked here, so all of these properties are useful in determining the molar mass. So that is the general statement. But in case of macromolecules, why specifically osmotic pressure is preferred to calculate or to determine the molar mass? Let me explain. First of all, let us try to understand. We will take either elevation of boiling point or depression of freezing point. Let me consider delta Tb is proportional to molarity. That is, molarity is nothing but number of moles of the solute. 2 represents a solute, 1 represents solvent. So number of moles of solute divided by weight of the solution. Let me say weight of the solution. Okay, is it clear? Right. Now, here in the case of, that is osmotic pressure, pi is equal to N2 divided by V into RT. Let me consider R and T are constant. So in that case, it is proportional to the molarity. Am I right? Because M is equal to number of moles divided by moles of the solute divided by volume of the solution. So let me consider proportional to M. So pi is proportional to M, that is molarity. This capital M represents molarity, R-I-T-Y. Whereas here it is small m. So this small m is nothing but molality. Okay. Now let me further expand this. There is a relationship between molarity and molality. So I will explain based on this. Here molarity, molarity is equal to weight divided by molecular weight into 1000 divided by V, where V represents the volume of the solution. Since I have put 1000, this is declared in ml, but the final value is declared in mole per liter. So as I already mentioned, 2 is the weight of the solute. Here M2 is the molar mass of that is molecular mass of the solute. Now molality means weight by molecular weight into 1000 divided by W dash, where W dash is the weight of the solution. Since we have introduced this 1000, so the gram becomes a kg, so its final unit is mole per kg. Now density, we know mass by volume, that is weight of the solution divided by volume of the solution. So we have got this W dash. So based on this equation, we can interpret W dash as D into V, that is density into volume. So M is equal to, I am now replacing this W dash. So M is equal to W2 divided by M2, okay. Then into 1000 divided by, instead of W1, I am writing this dV. So I put dV. So from this I can further convert W2 by M2 into 1000 divided by V, which is nothing but that is molarity. Is it not? So molarity. So I can simply incorporate here. So D, 1 by D. So molality is equal to molarity divided by D. So do you understand this? Right. Now let us further explain this. Here it may take a, let us go through once again this what I call the colligative property based problem. The osmotic pressure is preferred criteria than elevation boiling point and depression boiling point, okay, a freezing point. So let us discuss one by one. Elevation of boiling point is directly proportional to molality. So when we remove the proportionality, you have to introduce the constant. So this is called molal elevation constant or ebullioscopic constant. So delta TB is equal to KB into M. And M is nothing but N2 by W1. So once again we can expand it, but I want to insist on this formula. This is very important. Now pi. So here it is proportional to capital M, that we have already explained. So when it is expanded, we are able to get this equation. So my point of view is this one is very important. So in the case of determination of molar mass, how we calculate molar mass? This N2 is further expanded as M2, is it not? So in both the cases we are able to get this molar mass. From pi you can determine the molar mass, and similarly from delta TB we can determine the molar mass. So there is no doubt about that. But our question is, why elevation of boiling point is not preferred, rather this pi, that is osmotic pressure, is preferred as far as macromolecules are concerned. So we have to answer this. Now as we know, delta TB is proportional to molality. So this term is molality. Okay, try to understand this. And what about this? This is molarity, R-A-T-Y. So we have got already the relation between molality and molarity. So M is equal to M divided by D, where D is the density of the solution, right? So delta TB, now let us replace this M by D. So it becomes delta TB proportional to M by D. Now look at this. When the density increases, molality decreases. Am I right? Okay. When the density decreases, molality comes down. When the molality comes down, naturally elevation of boiling point will come down. So in that case, the elevation of boiling point value will be very, very small, and it is very difficult to measure. Do you understand? For macromolecules, because the density will be high. So higher the density, do you understand? Higher the density, less will be the molality. Since molality is less, then delta TB is already less. See, when you consider elevation of boiling point, you cannot say, for example, 100 degree Celsius or 373 Kelvin for boiling water. So when I say elevation of boiling point, don't think that this will be 150 degree by adding some solute. No. So this will be very marginal, like 100.02, like that. Are you able to follow this? So in that case, this is already delta TB is very, very low, and it is very difficult to measure such a low difference in the boiling point, that is temperature. Okay. So if it is the case, when the density is higher, definitely this will be much lower. So it is very difficult to identify such a very, very small distance, small difference in the case of boiling point, or in the case of freezing point. That is why this delta TB is not a preferred technique. Delta TF is not the preferred technique. Whereas in the case of macromolecules, pi is preferred because it is based on the molarity. You may wonder how this molarity and molality differs. For example, let me work out. So what is the formula for this? This is M is equal to M by D. I will calculate like this. For example, when I say that is the molarity is 5 moles. Let me say molarity is 5 moles and we are calculating M, and the density of the solution is say about 1.25. So in that case, you just look at it, what happens when you divide 5 by 1.25, that is 5 divided by 1.25, it drags the value to 4. Do you understand this? So this becomes 4. So you just imagine this is molarity, this is molality, that is 4 moles only. You just imagine this is 4 moles per kg, whereas this is 5 mole per liter. Do you understand? So since it is a higher value, now you look at it, that is the M is greater, therefore the pi is more appreciable. I hope now it is very, very clear that compared to the other colligative properties, the magnitude is appreciable, large enough for calculating the very dilute solutions of macromolecules because of the density is of higher order. Are you able to understand this? Thank you.